Hi guys, welcome to Engineers YouTube channel. Today we're going to learn about the concept of Kmap. First, what is Kmap? How is it used? Kmap is also known as, it is basically known as the Karnaugh map. It is used to simplify a set of variables in such a way that it is more efficient and less in cost by simply like removing the redundancy pairs. The topics I'm going to cover is 3-variable Kmap and 4-variable Kmap. So let's first begin with a 3-variable Kmap. So what is a 3-variable Kmap? It is nothing but it consists of 3 variables. For example, let's consider the function f abc is equal to sum of min terms. Numbers I'll give 1, 2, 3, 4. This is just an example. The concept, if you understand, then it will be very easy to score very good marks. Like it can be asked for around 6 to 10 marks. So first, how do you know what is 0, 1, 2, 3, 4? Plot the truth table. So since there are 3 variables a, b, c, followed by function f. So now there's a trick to remember how to put the numberings for ABC, the truth table. So since this has 3 variables, we're going to take 2 to the power 3, which is 8. So totally there will be 8 number of rows. So if there are 8 number of rows, for the A, column A, we're going to take 8 by 2, which is nothing but 4. Because why we take here the number 2 is because we are representing in the terms of binary. And binary numbers have 0 or 1. Okay. So here A will have either, it will have 4 zeros and 4 ones. So how do we do it? 1, 2, 3, 4. So 4 zeros followed by 4 ones. Okay. Next, for B, it is 4 divided by 2. This number divided by 2, which is 2. So the pattern will go as 2 zeros followed by 2 ones. Okay. So here if you actually check, we have 8 columns. Sorry, rows. Okay. And in truth table, usually we start with the number 0 to count the number of rows. And for the column C, it is going to be 2 divided by 2, which is equal to 1. So the pattern will go as 0, 1, 0, 1 and so on. Okay. Now, since we have the function as 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4. So first, the key concept in this is wherever there is 0, like the numbers mentioned in this will be plotted as 1. So it is considered as high. So since 0 is, row 0 has 1. So here we name it as 1. Similarly, for row 1 it's 1, row 2 it's 1, row 3 it's 1. Okay, row 3 it's 0. I have not mentioned it in the example. And row 4 is 1. So the rest of the variables which are not mentioned in this function remain low, which is nothing but 0. So 0 stands for low, 1 stands for high. In this we have used M0, M1, M2, M3, M4, M5, M6 and M7. These are the min terms. The same thing can also be represented as max terms, which in the case it will be given as, suppose, pi of capital M, whichever numbers are not mentioned here, which is nothing but 3, 5, 6 and 7. So if you observe, this is capital M0, M1, M2, M3, M4, M5, M6 and M7. This particular concept is for min terms. And when 0 is high and 1 is low, this concept is for max terms. Okay, so now we'll learn how to plot these variables in a Kmap. A 3-variable Kmap consists of 2 rows, which is, for example, we've taken A, B, C here, A and A bar. Okay, and it will consist of 4 columns. Because when you see B and C will have maximum of 4 combinations, 0, 0, 0, 1, 1, 0 and 1, 1. Whereas just A will have only 2 combinations, 0 and 1. Okay, so we take this as 2 rows and 3 columns. Next, the numbering. So this is A and A bar. This is B bar, C bar, B bar C, B C and B C bar. There's only one main rule in a Kmap, that the difference between, suppose, B bar, C bar and B bar C, there should be only one difference. That is, one variable should be different. In this case, we have C variable as different. Only then can we take it common. So what we do here, why I have named this as BC and this as B bar C, because when you consider 0, 0, 0, 1, 0, 1, 1, 0 and 1, 1, this is nothing but 0 is considered as bar and 1 is considered as nothing. So here we take it as, suppose this is A and B only, A bar, B bar, A bar, B, A, B bar, AB. Now if you observe, between these 2 rows, you have B's variable is changing. Between these 2, we have A variable changing. Now, between these 2, we have the variable B changing. So, in this case, when we take it as 0, 0, 0, 1, 1, 0, 1, 1, 1, 0. Okay. Here, the C variable changes. C variable changes. Among these 2, B bar C and BC, the B variable changes, and these 2, C variable changes. So this is the main concept which you should remember, how to name, because naming carries a lot of marks in exam point of view. Next, numbering 0, 1, 3 and 2. Again, as I told, 0, 1, 2, 3. Since we have given this row as BC, which is nothing corresponding to 1, 1, therefore cell number is 3. And then here again 4, 5, 7 and 6. Okay, this is the numbering. Now let's consider plotting these values in the Kmap. Now we have high for 0, 1, 2 and 4. Wherever you have the cell number 0, 1, 2 and 4, place it as 1. The rest you can place it as zeros. Okay. Now, yeah. So now the main part is mapping it. So in a 3-variable Kmap, you can do maximum mapping of 8. That is octet. Consists of 8. Next highest is a quad. Okay, which is 4. Then comes a pair, which is 2, and a single, which is 1. Now, in this case, if you observe, this is one pair. First of all, you have to check whether a quad is possible. Quad can be either, quad possibilities are 0, 1, 3, 2, 0, 1, 4, 5, 0, 4, 2, 6, 4, 5, 7, 6. Okay. And again 1, 3, 5, 7. There may be more combinations, but these are usually what are asked in the exams, and most of the questions, to be tricky part, will be asked one of these combinations. So since here in this question we don't have any quad, if you observe 0, 1 here, 5 is not 1 and 6 is not 1, these 3 are 0. So we consider this as highest will be a pair. Okay. So now first pair we found is this. Second pair is 0 and 4. Now many people might make a mistake of pairing this single, which is completely wrong. Okay. So what you have to pair it as is, you can take this one and this one. That is, pair is 0 and 1. I'll just erase this. Pause the video if you want and you can copy it down. 0 and 1. So the pairs which I have in this question are 0, 1, 0, 4, 0, 2. Okay. So in this question we have total of 3 pairs. Now how will you name it? How do you find the variable name? First thing is, now for pair 0 and 1, we have the row A, so A remains common, and the columns are B bar C bar plus B bar C. Okay, so this is nothing but A into B bar C, and B bar C bar have B bar in common, which is nothing but C bar plus C, and by the theorem we know this is equal to 1. Therefore first pair is A B bar. Okay. Second pair we have 0 and 4. So A bar plus A bar into B bar C bar. Now again we know A plus A bar is equal to 1. So this is nothing but B bar C bar. Similarly, third one, A is common. We have two rows which are columns which are used. B bar C bar plus B C bar. So C bar is common. A C bar into B bar plus B. So B bar plus C is equal to 1. So A C bar. So your final function F A B C is nothing but A B bar this plus B bar C bar plus A C bar. Okay, this is your answer, final answer. Now in the exams the steps are not asked much. So you have the question. If it is a 5-mark question, for example, truth table doesn't carry marks. Writing of the Kmap carries 2 marks, like having the correct numbering of the Kmap, followed by marking the Kmap is 1 mark, and your final answer is 2 marks. Sometimes they may ask usually to name the pairs which you have already formed. So here 0 and 2 will be A C bar, 0 and 1 is A B bar, and this is B bar C bar. Okay. So as a whole, for exam point of view, this is all they ask. So this is the concept of a 3 variable Kmap. Now in case if you have a doubt, if they ask what about this, if these two are asked, right? So guys, just know one thing, I am teaching only the SOP part, SOP. Okay, POS I'll cover in another video because it is a completely different concept which may confuse if you learn everything at a time. So you know how to form pairs now. You can take an example of quads and you can take an example of octet. I'll leave a few questions at the end of the video. So try to solve them. Any doubts, drop a comment so that I can solve those questions in the next video. Okay, next let's continue with 4 variable Kmap. A 4 variable Kmap, as a name suggests, consists of 4 variables, a function of 4 variables, sum of certain numbers. Let's take the example. So a 4 variable Kmap consists from numbers 0 to 15. Okay, 0 to 15 are the number of rows you'll have or the number of cells you'll have in a Kmap. So 0 to 15 So see, when we had a 3-variable Kmap, since there are 3 variables, so we have 2 rows and 4 columns. But since it is a 4-variable Kmap, we have 4 rows and 4 columns. Naming is as follows: A, B, C, D, A bar, B bar, A bar, B, A, B, A, B bar. Okay. And this is C bar, D bar, C bar, D, C, D, C, D bar. If you have understood the concept of how I'm naming it in a 3-variable Kmap, it's the same thing, just that I'm adding another variable. So I take it as A, B and C, D. Cell numbers. As you know, 0, 1, 3, 2, 4, 5, 7 and 6. Now since there are 16 rows, the 4-variable Kmap has 16 cell numbers, because as you know, 2 to the power 4 is equal to 16, right? So it will have 16 rows. So this will nothing but here. So 8, 9, 11, 10, 12, 13, 14 and 15. Now, like how I have swapped these two rows and columns, I have also swapped these two. Same concept which is used here is also applied in this part. So if that changes, since we change 3 and 2 here, in this case we'll change these two. Okay. Let's continue. So now let's take an example of having 0, 2, 8, 10 and 2, 8, 10, 1, 5, 13 and 9. Okay. This is usually asked in order, so let me just rewrite it so that it is better for understanding. 0, 1, 2, 4, 5, 6, 8, 9 and 10, 12, 13 and 14. Okay. So these are your cell numbers. See, truth table is optional. You can use it. Probably you can apply the truth table concept for the first four sums you solve if you're doing this for the first time. I'll just show it to you once in case you're confused about a 4-variable truth table. Okay. So as in a 3-variable Kmap, if you've understood the concept, again 2 to the power 4 is 16. So for A, 16 divided by 2 is 8. So we have 8 zeros followed by 8 ones. Then for B, 8 by 2, which is 4. Then for C, 4 by 2, which is 2. So 2 zeros followed by 2, 1, 2, 0, 2, 1, 2 zeros, 2, 1, 2 zeros, 2, 1. And for D, 2 by 2, which is equal to 1. So 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay. And function again, M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, okay. So as you can see, 0 to 15, as I told in the beginning here, 0 to 15, I have 16 rows, and this is how the truth table is plotted. So correspondingly, see the numbers you have here, they will be 1, 1 and so on. Okay, let's plot the numbers in the Kmap. So now we have 0, 1, 2, 4, 5, 6, 12, 13, 14, 8, 9 and 10. The rest, as you learnt in 3-variable Kmap, it is 0. Now, the main part comes to the plotting. Okay, so let me just move this part down so that I have more space to finish this particular question. Okay. So now, plotting, as I told, octet, is 8, quad is 4, pair is 2, single is 1. And a small trick to remember for a 4 variable Kmap, an octet will have one literal. Literals are nothing but the variable names, okay? Suppose A is a literal, B is a literal. So quad will have 2 literals. A pair will have 3 literals. And single will have 4 literals. This is a small trick you can remember while revising a concept. So in this case, many of you may misunderstand that it will have 3 quads. In reality, I took this example to show how octets work. Octet is 8, right? So when you take 0, 1, 2, 4, 5, 12, 13, 8 and 9, this forms an octet. Correct? So if it forms an octet, you will have how many literals? As we learnt, 1 literal. So this is 1 octet. Okay, so 1 literal in the sense, this nothing but corresponds to literal. See, amongst these 4, there's nothing common. It all cancels out. And among C bar D plus C bar D bar. So among this, if you take C bar common, D plus D bar is equal to 1. So C bar. So your answer for this literal is nothing but C bar. Now, some people may also have the misunderstanding that it has 1 quad and 1 octet. In reality, when you fold the sheet together in a cylindrical form, this also forms a octet. Okay, this forms an octet. So this octet is nothing but, again, when you do all the how I taught to take commons, that way this is D bar. So your final function, nothing but C bar plus D bar. That's all. This question was asked for 10 marks. So see, this is basically a concept where it's easy scoring for a person, and you also understand how you take common, how you name the literals, how do you name the cell numbers of a Kmap. So that's it for this video. I will continue for the next video. Will have POS, and I'll also teach don't care conditions in another video. This is not very common. It was there in 3rd semester of engineering for computer science and probably EC. So don't care condition is there. Then you have gates. Gates is a very important topic, and implementation of gates. So these are a few questions which are very commonly asked. Okay, I will leave the questions which you can solve on your own. Leave the answers in the comments. I will check, and if there's any doubts, feel free to comment it down so that I can teach it again. Okay, thank you. Bye-bye. And like, share and subscribe for more such content on engineering concepts made easy. I am just doing this as a time pass, and I love to spread knowledge, and I just want to make it concepts of engineering easy and not like a burden for others. Okay, thank you. Bye bye.